making an incision here, hopefully this is going to go right to the tumor. All right? I was hoping, some of the surgeons would be here to tell me just how good they are without this. But so this Dr. Moore that, sorry, what was that?
Surgeons are always good.
Of course they are. Yeah. You think, the more I hang out with neurosurgeons, I figure that I want them to be as self-confident, perhaps overconfident as they are, because I don't want someone to open up my head and then sort of not be sure. Right? Okay. You're going to make an incision, make it. Right? So, but when I was in, I got a taste of conventional medicine again when I was at this Canadian hospital, and they showed me how you can go and make a craniotomy, halfway through it realize that the tumor isn't where you thought it was. You have to go and create a second big hole in the head. Now you've got 2 pieces of bone you've taken out. Think about it. It's like that much more healing that needs to be done, that much more infection to the patient, right? And worst case is if you make an incision you make a craniotomy in the wrong place, and you end up taking out what you think is the tumor there. The patient goes back, you think you've done your job, the patient goes back, has their seizure again, and then you say, an MR is done, or typically an MR is done post-operatively, and you find out there's a tumor left. And just the trauma of that on the patient, and on the surgeon itself, contrary to the jokes we're making, surgeons take, it's all about their ego. And I'm glad it is about their ego, because they want to do a job as well as they can. A patient coming back for a revision simply because part of the tumor was missed, it's an insult to the surgeon. And I'm glad they feel insulted, because they won't do it. So these are very, these are the sorts of things that really motivate me to stay in this field. And we use probability to achieve these images. I was thinking there was a message in here somewhere that related to your class, but
Can't you find a better word than probability?
I'm sorry. Yeah. I like it. Like likelihood. You like that? Okay. Sure.
Absolutely 100%.
So here's how this relates to this class. Those MR images in the final project that we do, which final meaning starting Monday, what we do is I'm going to give you some MR images like the ones on the left. We're going to load them into MATLAB, and then what I'm going to ask you guys to do, and I'll walk you through that, is we will create what is called a segmentation of those images. Anybody heard the word segmentation before in this context? No? Not market segmentation, but this. Okay, so the idea is if you look at the grayscale images on the left, you can think of that, I keep losing this mouse here. It's gone. The grayscale images on the left don't have clearly demarcated boundaries of, what is white matter, what is gray matter, where is the tumor. These are all numbers in those images between values from 0 to 256. Some of them are going to be white matter, some of them are going to be gray matter. In some cases, white and gray matter are going to have overlapping intensities. Does everyone know what I mean by intensity in an image? Yeah? Anyone care to take a shot and explain it? Just so if somebody's feeling too shy. No? All right.
Are you just talking about that scale of 1 to 256 or 0 to 256?
Exactly. Yeah. Thank you. Yeah. Yes, exactly. So this image, the images on the left, if you just take one single slice, that is a 2-dimensional array of the width is 256, height is 256, and each of the values in that array is a number between 0 and 255. Okay? Now, if the number is 255, it's going to appear bright in that image. If the number is 0, it's going to appear dark in that image. Okay? Those are the intensity values that I'm referring to. Now, white matter, for example, in the brain there's the white matter and the gray matter. Gray matter is the outer cortex where all the nuclei are, and gray matter and white matter is the inside. So gray matter is the stuff that grows when your parents read to you when you're kids. Have you seen those Nova or whatever shows where they show, a child that was never read to, thin gray matter, and a child that was read to a lot, very thick gray matter. So that's now, in order to be able to create visualizations like the one on the right, where the tumor shows up bright green. You know, it's one single defined surface as opposed to a bunch of changing intensities, which a tumor really is like. In order to be able to go from the images to the left to the images on the right, the first task you have to do is segmentation, which is to associate with each intensity level, each pixel value in your image on the left-hand side. You've got to associate a class with it. You have to say, is this brain? Is this tumor? Is this ventricles, or is this blood vessels? Okay. On the right, the red are the blood vessels. The green is the tumor. Maybe you can see a hint of the blue, that's ventricles. They're deep-seated structures where there's cerebrospinal fluid, CSF. And the whitish gray mass is the brain, and then there's the skin rendered over there. Okay? So in order to be able to render images like the one on the right, you have to do a segmentation or a labeling step. Okay? And that's everything that I do today is basically I want us to be very familiar with the vocabulary that we're going to need in order to do the segmentation step. Today I'm basically, we'll go over the vocabulary real quick. Then I'm going to spend, I have some MATLAB exercises that I've planned just so that you guys are familiar with the terminology that we're going to end up using on Monday and Tuesday. So we'll do that today. Monday we're going to start the project, Tuesday we're going to finish the project. Shai just told me that we could continue on Wednesday morning if we needed to. So we'll see where we are on Tuesday, and if we feel that we want to spend more time on the project, which I think is going to be more fun than the exam. Well, maybe I can even talk Raj into making the project in lieu of the exam or something. If you had a chance. So we'll do that, and what I'd like to do is keep the lectures at 10 and start a lab at 11 if you guys are okay with that. I will start because I don't think of the second part as a recitation, especially since Raj tells me that people think recitation is optional. Because the lab is really where what we're going to do is, we'll go over some theory in the morning, and then we're just going to go sit on our computers and write MATLAB programs to actually do the segmentation. Okay? Anybody who cannot make this new lab time? No? All right, let me know, and we can always go over this stuff separately. Let's see. So yeah, I'm just going to have two problem sets. One will start. My hope is that the handout that I'll give you in the lab, it's going to be a bunch of exercises to go through, and that's going to be your problem set. My hope is you're going to just be able to finish that in the lab time. So there's going to be no homework per se. And the best case, of course, is that you love MATLAB after the end of that hour and a half when you sit there for the next 20 and just learn all these other things about it, but it's not going to be part of the grade. All right, so here is the fundamental vocabulary we need in order to be able to do our segmentation problem. Okay? Some of these things, I think, maybe most of these things you guys know already from the previous lectures. Here's a candidate for a pop quiz. Oh, sure, that's just Shy. I don't know, we were just starting a pop quiz with all the folks wearing Ars Digita t-shirts here. All right. So here, I'm going to go over this vocabulary, and pardon me if it's repetitive, but I really want to make sure that everyone has an intuitive understanding of what these things are, because once you start writing code for it, you need to know more than just the definition. You need to be one with the concept. So that's what we're going to do. And I'm just going to go through all of these. Probably the only new ones here from the lecture are Gaussian and uniform PDFs. Or have you've done a little bit of uniform and recitation, right?
We talked about both of them.
Oh, you have talked about, perfect. So we can even, good.
As Chris says so, doesn't mean everybody.
Yeah, well, we're going to go. Hey, all right.
If you could just explain those.
Oh, I'm going to go over all of these. Oh, this is the lecture. This is the full. Yeah, this is the full lecture. So after I go over the uniform and the Gaussian, what I'm going to do is Bayes' rule that you guys have gone over many times in different iterations. That's one thing we really need to be one with, because that is going to be underlying your segmentation problem. Okay, so I'm going to go over that, reformulate that in the terminology that we're going to be using. And if you guys have questions on all of this, today would be a very good time to ask them. And you can ask Chris? Is that- all right. Whoever is nodding their head vigorously, you can ask them to do your problem set.
Even if we provide segmentation involves probability.
I'm sorry.